Lusen wrote this in the margins as he was studying a mathematical problem in set theory. Quote, "Each definition is a piece of secret ripped from nature by the human spirit."
Each definition is a piece of secret ripped from nature by the human spirit.
I insist on this. Any complicated thing, being illumined by definitions, being laid out in them, being broken up in pieces, will be separated into pieces completely transparent even to a child, excluding foggy and dark parts that our intuition whispers to us. By separating the object into logical pieces, then only can we move further towards new successes due to definitions, unquote. By linking naming to mathematical definition, and by describing definition as, quote, a piece of secret ripped from nature, unquote, Lusen revealed his differences both with traditional mystical views of naming that I've already discussed a bit, and also with Western rationalism, especially the French form so followed by his mathematical colleagues in Paris. According to the ancient Greeks and many later mystics, naming was a way to gain a power over a thing that you name. But Lusen believed that naming was a two-way street, involving both losses and gains. When one named something, Lusen thought one gained in effectiveness, what he called, quote, new successes due to definition, unquote, but one at the same time also lost what he called, quote, the foggy and dark parts our intuition whispers to us.
The foggy and dark parts our intuition whispers to us.
Thus, to Lusen, naming and definition are the awkward, incomplete, and inadequate tools that we must by necessity use in order to do mathematics, but which fall far short of encapsulating the entirety of the objects they allegedly describe. Lusen saw this as being at the heart of the field of mathematics he created, which is called descriptive set theory. According to French rationalists like Borel, Lebec, and Bayer, one should follow Descartes and, quote, commence with objects the simplest and easiest to know and ascend step by step to the knowledge of the more complex, unquote. But Lusen differed fundamentally with this form of logical reductionism. To him, the entirety of an object is far greater than its individual characteristics that might be named or described.
You know, in 17th century, most people believed in God. I'm not saying it's good or bad. I'm not saying we should or should not believe in God. But there's one aspect of it. If you do believe in God, you accept that there is something ineffable, something that cannot be explained, something beyond all logic and reason. Are we really willing to sacrifice that? So today, perhaps we've lost that, and we decided to believe in science, which is great. Let's believe in science. But let's not, number one, make it into a new religion. And number two, let's not be so selective. Let's not believe in science as it was in the 17th century. Let's accept all of science, everything that science tells us. Let's accept all the achievements of science in the last 100 years. Quantum mechanics, relativity, Gödel's incompleteness.
Quantum mechanics, relativity. Gödel's incompleteness.
Let's take all of that into account. Why don't we do that? And you know, A friend of mine, I discussed this with a friend of mine. He told me about the psychological condition, which is called anosognosia. So I've been reading about that. It's a very interesting psychological disorder when our logical people somebody may have a severe disability, for example, paralyzed limb like an arm or a leg, but their mind, their logical mind, is convincing them that that's not the case. So you'd have a person who would have a paralyzed leg, but he would say, tonight I'm going to go to a dance club, tonight I'm going to, and then when you ask that person, so did you go? Oh, I couldn't go because I was busy. So in other words, you find excuses and arguments and you explain to yourself why you couldn't do it instead of facing the reality. Instead of facing the reality of your condition. Anosognosia. Is that becoming our common disease? What exactly are we trying to run away from? What exactly is it that we are afraid to face? And another point is they talk about the body as if it is this fixed object, like this podium. But we know from biology that the body is constantly rejuvenated. All the cells are constantly rejuvenated. It's this constant motion, of us and the universe. And we're all connected by this. It's not, you don't have to listen to a guru, you don't have to go to listen to spiritual teachers, who, by the way, have been saying that all along. Modern science tells us. So we believe in science? Great. Let's take that from our science.
The statement here is that the perception of mathematical truth cannot be reduced to a set of mechanical rules.
The perception of mathematical truth cannot be reduced to a set of mechanical rules.
And this comes from a famous theorem due to Gödel, and Turing was certainly very familiar with this. It featured very much in his 1936 paper, the original one, because he was very much concerned with things that computers couldn't do, if you like. That was part of what he was trying to do. And so as to say what you couldn't do by a mechanical procedure, he had to define what he meant by a mechanical procedure and then show that there were certain things that you can't do with a mechanical procedure. Well, I'm going to phrase Gödel's theorem in a way which it's not normally phrased, but it is a perfectly correct deduction from his theorem. Tells us that for any mathematical theorem, and that's the kind of thing I'm talking about here with natural numbers and so on, it tells us for any set of mechanical theorem-proving rules, and when I say mechanical theorem-proving rules, I mean you have a set of procedures which can be checked by a computer. That's the crucial point. If you follow these rules and you come to a conclusion that it proves some mathematical statement of the kind we're talking about, then that alleged proof can be checked by a computer. So that's the kind of rules we're talking about. Then what you can construct is a particular mathematical statement, which Gödel shows you how to do, and I'm calling that G of R, which if we trust the rules, if we believe in the validity of the rules, that is to say, if we believe that anything we derive using the rules must be true, if you trust the rules, then you must also believe that this particular statement, G of R, is true. Yet, it cannot be proved using the rules. Now that's a very striking, remarkable thing, because what it's telling us is that whatever these rules are, if they're rules whose consequences we believe in, then that belief or that trust extends beyond the rules themselves.
Now that's a very striking, remarkable thing, because what it's telling us is that whatever these rules are, if they're rules whose consequences we believe in, then that belief or that trust extends beyond the rules themselves.
And that's you have to know that the rules are trustworthy, and that belief that they're trustworthy enables you to extend beyond the rules, so that this particular statement, G of R, cannot be proved using the rules of R, but the way in which it's constructed tells you that it's nevertheless believe it's true. See, people usually state Gödel's theorem in a rather negative way. They say there are certain things you can't prove. But what they mean is you can't prove using a very specific set of rules, but if you trust those rules, then you can see that statement is true. And this is a very striking thing about the Gödel statement.
See, people usually state Gödel's theorem in a rather negative way. They say there are certain things you can't prove. But what they mean is you can't prove using a very specific set of rules, but if you trust those rules, then you can see that statement is true. And this is a very striking thing about the Gödel statement.
And clearly Turing was very much aware of this, and that
and if you don't know, now you know.